Hello, welcome. Today let's try to solve another Leetcode problem, 1713, minimum operations to make a subsequence. So we are giving a target array and an array. So the target is 5, 1, 3, and our array is 9, 4, 2, 3, and 4. So we just need to add some numbers inside the array to make this target array is the subsequence of this array. So for example, there's already has a number 3. It means it has a 3. We just need to insert a number 5 and 1 to this array. So 5 and 1 inserted here or anywhere just makes the sequence the same. You're gonna get the right result. So yeah, put the 5 here and 1 here. It is okay. So it means we need to insert 2 positions. We need 2 insertions, so we're gonna return a 2. Yeah. So for such things, it's very clear. It's the longest common subsequence problem, because if this 3 is the longest common subsequence, here we have a 3. So the length of the target minus this number 3, because we find 1, it is a 2. So it is the result. So this is actually the template code for the longest common subsequence. So here is just the template code. If you solve the longest common subsequence, it should not be difficult. Yeah. So here is just the length of the target minus the longest common subsequence with those 2 arrays, target and array. Let's check the values length of the array. It is 10 to the power of 5. And it will not pass. Now let me just run it and submit it to check if it is okay. Because for Leetcode, if it is more than 10 to the power of 4, normally it cannot pass for a O(n) square time complexity algorithm. Now let me submit it. You can see that it will not pass. Yeah, just wait for a few seconds and let's check the result. Because this is the O(n) square, 10 to the power of 10, of course, it will not pass. Yeah, but our idea is the same. If this number is 10 to the power of 3, of course we can pass. Yeah, so there is a time limit exceeded error. So it means our algorithm is okay, but the time complexity is not okay. So we need to increase our time, increase the speed and reduce the time. So how should we do that? Let me uncomment. Let me just delete this one. Let me uncomment this one. Maybe you will check something. Yeah. So let me just comment this one. Now we are going to use another method. It is called longest increasing subsequence. Yeah. So sometimes the longest increasing and the longest common subsequence can be converted to each other to solve different Leetcode problems because they are really similar. Now we are going to check. So in the target array, let me prepare 2 arrays, target and array for this example. So let me put it here. Yeah, actually, let me just delete this one to make it clear. So we have a target and array. So here is this 3. So the index of this 3 is 2. And here we also have a 3. We don't care about this index. We just take care of this index. Yeah, because we're going to use O(n) log n time to solve this problem. Can we use the index to make the index longest increasing? To make the index be a longest increasing subarray to solve the problem? Yes, we can. Because for this 3, as the index for the target is 2, so we're going to name it an index as 2. Put it inside our array. Yeah. If we have another number, maybe 5 here. So for 5, our index is what? So the index for 5 is 0. Yeah. So for such arrays, the longest increasing subarray is 1 because 2 is more than 0. So it is 1. But for example, we have another array. Maybe here we have a 5. So the index of the 5, let me prepare the index. So for our target array, we have a number with index. So 5 index with 0, 1 with index of 1, and 3 with index of 2. So this is what we needed to prepare. We needed to prepare basically a dictionary. So this dictionary have k-value pairs. So k is the number inside the target, and the value actually is the index. Because we're gonna use we're gonna check the index to check inside this array, and these numbers we're gonna check each index of them. If the index is in increasing order, and we're gonna check the longest increasing subsequence of the index. If it is a 3, it means we're gonna get a result of 0, because the length of the target minus 3, it is 0. Now we are going to check it. So for this example, now for the first one, we are not going to check the numbers which are not inside the target, because we're only considering with 5, 1, and 3. So if this is 5, we got an index, it is 0. So from the beginning, we have a 0. Now we have another number, it's here, 3. So the index for 3 is 2. We have another number, it is 2. Now we are going to check this array. What is the longest increasing subsequence? It is 2. So this is why we're going to use the length of the target 3 minus 2. It is 1. So for here, it is 5, 3. This is for 5, 3, and here we have another 5 and 3. This is why we can solve it in O n log n time. Because longest increasing subsequence, there is a patience sort algorithm can be solved in O n log n time. So actually, this is the template code. For the strictly increasing, it is just you need to use a bisect left. If it is not strictly increasing, it is a non-decreasing, you can use a bisect left. And for our problem, it is strictly increasing, so I'm gonna use a bisect left. Now, the second step is so this is the template. The second step is to prepare this dictionary. So how should we prepare this dictionary? So for the dictionary, it's gonna be a k-value pair. So the k will be the number, and the value will be the index. So n with index for in enumerate target. So for this one, we've already prepared the dictionary. Now, inside our longest increasing subsequence function, we just need to change this number n with dn, because we need to check the index as the result. Because for this array, longest increasing subsequence, actually we are just checking the index. Inside, actually it is the index. We're just checking the longest increasing subsequence of the index inside the array. Now for here, it's also the same. We just need to change it to dn, and this one also the same. Because we just need to append or insert, put the index inside, not the number itself. Now let's check. And for this n inside the array, before we use the bisect left, because we used to check this dn. So for this dn, this n must inside the dictionary. So if this n inside this dictionary d, so we're gonna check. We just need to change a little bit for the template of the longest increasing subsequence for this O n log n time template. Now, let's say what we needed to do. We just needed to return the result. So let me delete 2 empty line. We just needed to return the length of the target and minus, let's say, L. So this is LIS, and with the array. Basically this is the longest increasing subsequence for those indexes. If this is right, we just need to use the length of the target minus the longest increasing subsequence for those indexes, like 0 and 2. Now let me just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass for all the testing cases. Yeah, as you can see, let's just wait for a few seconds. As you can see, it passed all the testing cases and it's pretty fast. And by the way, the time complexity is just O n log n. Now let's just check why I use left. Because the numbers inside of the target, as you can see that there are numbers inside of the target, and with these numbers, the index is always be unique. If the index is unique, so it means for the index, it is strictly increasing. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.